Hello, guys. Welcome to my. Today I'm going to do a comprehensive explanation on what DevOps engineering really means, and I'm going to explain some of the concepts. So, come with me. Let's go on this journey. Like this video, try and share with your friends and family, subscribe to this channel to follow some other sequel to this very video. So let's start with what we are here for today. The first thing is, what is DevOps engineering? Oh, yes. So I need to explain this concept because there have been a lot of questions of what DevOps engineering really means. So I have a few definitions that will help you on this. One of my first definition is this. DevOps is a software development practice that combines software development, and that is where the word dev comes in. Then IT operations, and that's where the ops comes in. So to shorten the development life cycle and provide continuous delivery with high software quality. So one of the major aim of DevOps engineering is we want to shorten the development life cycle, and while doing that, we also want to provide a continuous delivery with high quality. So we want to have a delivery of high software quality. So let me show you this. Okay, you can see this image. You can see there is a dev and there is a hops, and it looks like they are both at war. All right, even though they might not really be at war, but let me say this is one of the major concepts of DevOps engineering. There's always been a disparity, and then there's always been an issue between the dev team, the development teams, and the operations team, such that things that the development teams felt, oh, it's okay, by the time it gets to the operations, it brings out some issues. And this is one of the concepts that brought about the concept of DevOps, trying to solve the issues, the problems between the dev teams and the operations teams, whereby we can have our softwares developed properly with high quality within a short time, as much as we can have. So let me give you another definition. DevOps is a software development method that emphasizes collaboration, communication, and integration between software development and IT operations. So as you can see, we emphasize on collaborations. It means there must be discussions, there must be talk between the development team and the IT operations team, such that we can work hand in hand and produce a software of high quality. So what is the goal of DevOps engineering? One, the goal of DevOps engineering is to increase the speed, quality, and reliability of delivering software products to customers. And this is very important. The major goal of DevOps is we want our customers to be happy. We want to deliver something that is worthwhile to the customers. And this is achieved through a culture of continuous improvement, automation of processes. Yes, automation of processes, continuous improvement. And that is where we begin to talk about the concept of CI/CD. I think following this video, I will still do a sequel on CI/CD, explaining the concept of continuous integration and continuous delivery. So the goal of DevOps engineering is to build that culture of continuous improvement, automation of processes. That's when we begin to talk about versioning, begin to talk about Git and GitHubs, and use of modern tools and technologies. We have several modern tools and technologies that I'm still going to talk about in this video series. We have Terraform, we have Jenkins, we have Cloud Platform, and all of those things. We need to understand how these things are put together to make the delivery of software becomes easy and still giving a top-notch quality. So DevOps practices aim to bridge the gap between development and operations and promote a more efficient and effective software development lifecycle. I told you that's the aim. We want to develop, we want to produce something that is of high quality and still within a shorter time range. So the next question would be, who is a DevOps engineer? So I have a definition. A DevOps engineer is a professional who works with developers and the IT team to manage code releases. And he is responsible for ensuring a smooth production environment. So that is the work of a DevOps engineer. You have to manage the code releases and make sure that you have a smooth production environment. You will understand this by the time we get to the concept of building a CI/CD pipeline. A DevOps engineer introduces processes, tools, methodologies to balance needs throughout the software development lifecycle, from coding and development to maintenance and updates. Yes, maintenance and update, because the whole life cycle of a software does not stop when the software has been released. There must be maintenance, there must be updates, and this must not affect the working of the software. So these are some of the key roles of a DevOps engineer. He has to build a sustainable pipeline, a system that will allow all of this to happen and it won't affect the production, it won't affect the users of the software. Things will still go on smoothly. So let me show you this diagram. So as you can see, this is a diagram that explains the concept of software of DevOps engineering. You see, when you have an idea of 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 an app, let's say you just want to build an app that an e-commerce app, probably something that delivers food from one place to another. You have to first plan. Okay, you want to do what you are trying to work on. Then when you have your plan, you get into the coding. That's when you must have had your diagram, your UI, UX, and all of that. Then you get into the coding, and when you're done with the coding, you build the code, test it. Now, this is the concept of DevOps. The concept is this: when you release the code, you deploy it to operations, we test it there, and we monitor how your code works. So when there is any issue, there is always this other side. You can say the circle is moving. So you can always report any issue that comes up in the operations environment. Still, we plan on it. So this circle continues. So it's a continuous process throughout the life cycle of the software. So there's no bridging. There's no break between the devs and the operations teams. So we can always work hand in hand. And this is the whole concept of DevOps engineering. But before we come about DevOps engineering, before DevOps, how were software being developed? what are the modalities, how things were done before DevOps. So, and this will take us to this concept that we call waterfall model. Okay, this is it. Before the introduction of DevOps engineering, you have this model of developing software, which we call waterfall model. The concept of waterfall is this: when you have an idea, you put up the whole requirement. Oh, I need to build this. So I need a UI UX. I need a front end. I need a back end. You put them together. You put up your design. You do your development. You test it, and after testing it, you do your deployment, then you do your maintenance. Now, the shortcoming of this, as you can see, it's not a continuous process. It means when you are on stage 4 and you discover a problem that ought to be solved at stage 1, what that means is that every other stage had to stop. Then you return back to stage 1, and this will continue to waste time, waste resources. So it's not a continuous model. So this is the concept of waterfall, and this was the concept that was used before the introduction of DevOps engineering. So it's a traditional software development practices, and it involves determining a problem. Yes, we found a problem. You analyze the requirement, you build and test the required code, then you deliver it out to your users. It's usually all the steps above are referred to as waterfall approach. Yes, it's a waterfall approach. Just take the concept of rain falling. It has to touch whatever is at the top before it touches whatever is beneath. So that's the concept of this waterfall model. So the waterfall model follows a sequential order. It's more like you want to build uh, a structure, more like an engineer who wants to build a house. You want to erect a building. You start from the foundation, then you probably move to the lintel level and move to the stage where you have your roof and all of that. Now the challenge is this: when you are at the roof and you discover a problem at the foundation, what happens? You have to collapse the whole building, right? And start again. This is the concept of waterfall. And as good as it may sound, it does not encourages the life cycle of software. There were challenges, and that was why this concept began to we began to work on this concept, because it has drawbacks. And let me show you one of the drawbacks of this waterfall model. Waterfall methodology has some drawbacks, and I'm going to show just one of the drawbacks, and that is a drawback that is related to customer. A customer has come to you that, oh, software engineer, I want to build this app. So the customer gives you the idea of what he wants to build, and you start working. Now, usually the project will take a long time, and maybe a customer told you he wants to build something by January, and because writing code and all of that might take sometimes, let's say, 5 to 6 months. So by the time you are delivering the product to the customer by, let's say, June, the concept of what the customer discussed with you then by January might not uh, be what might not fit in to what is obtainable at the moment by June anymore. And that means the whole idea needs to either be worked on again, or you have to start all over again. And this is a concept that is not good enough. So there is a real challenge with gathering customers' requirement in the first place. If you are into software development, you will understand this very well. The customer has an idea, but he can only communicate the idea to you in the way he has an understanding of. So most times it takes a long time to deliver, and by the time you are delivering, you might not even meet the idea of what the customer is trying to tell you. Why? Because most often you will realize that customers don't know what they really want until they see it, or when they can really see the production of what they are trying to tell you. Sometimes they have an idea but they cannot explain it. So if a customer give you an idea and you are delivering to the customer in another 6 months, by the time you thought you've worked for 6 months, you might end up doing nonsense that doesn't even fit in the idea of the customer. And this is one of the drawbacks of the waterfall model. So because of this, we have to come up with a new approach, which is agile methodology. Okay, the concept of agile methodology is this. You see, as we go on this sequence, on this series rather, I will still talk about something we call microservices. That will be in another video, which will be sequel to this very one. The concept of microservices is, okay, you have a software we want to build where it has different pages. Let's say it has 5 pages. We can decide to cut each section of the software to different microservices, such that when we develop one, we test it, we run it, we know that it's fine. So we don't wait until we are done developing the whole software before we test. So as we develop every aspect or every part of the software, we test it and be sure that, oh, it meets exactly what we need. And this is the concept of agile methodology. You can see we have sprint one, we have sprint two, and you can have as much as you can, maybe sprint 100 and all. So the concept is to break each aspect of the whole software into smaller units, and you develop each aspect and you test it. This is the concept of agile methodology. So you don't have to wait until maybe 6 months, or the let me say the testing team has to wait until the front end and back end guys are really done with everything. No. So the idea is we test as we develop each aspect of the project. So by comparison, agile methodology constantly emphasizes adaptive planning and early delivery with continual improvement. So you improve it continuously. Rather than restricting development to rigid specifications, it encourages rapid and flexible responses to changes as they occur. I explained this already. In 2001, you see, highly regarded developers published manifesto for agile software development. Now, let me show you some of what they came up with. They said development needs to favor individuals and interactions over processes and tools. Working software over comprehensive documentation. What this means is that what is more important to us is that the software is working, not the many documentations. Customer collaboration over contract negotiation. So as you begin to work, you have a collaboration with the customer. Response to changes over following a plan. So when there is a plan at the beginning and there is a need to edit the plan, you do it immediately, and it can still fit in to the development of the software. So I'll leave you with some of this. You can read them on your own. Just pause the video and read. Agile software methodologies, these are some of the things they are based on. Now look at the last 10, and I want to emphasize on this. Agile software development helps team keep focus on business outcome. The truth is, when you're developing the software, we want to develop a software that is sellable in the market. We don't just want to develop a software that won't go anywhere. So it must be something that is sellable in the market. It must meet business requirement. And this is why you have to work together with the operations team and know what is really, really obtainable. And this is where the DevOps engineer comes in, trying to balance between the DevOps, the development team, and the operations team. So by comparison, you can go through this. You can see the comparison between waterfall model and the agile methodologies. So these are some of the principles of agile methodology. Let me just touch a few of them. One, our highest priority is to satisfy the customer through the early and continuous delivery of valuable software. And this is very important. No matter how good your software is, if the customer is not happy and your users are not happy, then you have only built a software that won't go anywhere. And this is the concept of DevOps engineering. We have to put in the users in mind. You can go through some of these other principles. These are some of the principles too. The simplicity, the art of maximizing the amount of work not done is essential. So it has to be, it has to be, you have to come up with a software that is really that meets the market requirement. And I'm going to show you some of the key benefits of DevOps engineering, because you need to know that this has some benefits. And these are some of the benefits. Faster time to market. Yes, with DevOps engineering, you can be sure that instead of spending several months, you can come up with the software within shorter time and you can be in the market. These are some of the key benefits. Improved collaboration and communication. I've spoken about this. Increased efficiency and agility. Yes, with DevOps engineering, the efficiency improves and the delivery becomes better than what it was before. So instead of spending several months working on a project and delivering little, DevOps engineering came up with a model that makes us spend lesser time and and delivering something of higher value in software development. So let me go through this, and this is very important as I try to as I conclude this very section of this video. After this video, there will be a sequel to this where I'm going to treat some of these tools one after the other, and we are going to have a hands-on practices on them. This is just an overview of what DevOps engineering really means. So we have some of the DevOps tools. We have the versioning control system, such as Git, and you have GitHub. GitHub is a website that uses Git. You get. So we have continuous integration. These are some of the tools. We have a tool that we use for continuous integration, like Jenkins, Travis CI, Circle CI. These are tools that you will need to use as a DevOps engineer. You need to know at least one or two of these tools. You have configuration management tools like Ansible, Puppet, Chef. We have Terraform. several of them. You may not need to know all of them in a particular category, but you can just pick one or two. For instance, for the configuration, you might learn Ansible, learn Terraform. We have the containerization tools like Docker and Kubernetes. This is very important. You know, the other time I was speaking about microservices. By the time you begin to talk about microservices, you will need Kubernetes and Docker. You will need all of this. Monitoring tools like you can see Zabbix, Datadog. These are some monitoring tools you can use. Logging and analysis tools. We have several of them in the market. So it's about the one you really need to use. And the number seven is something very important, cloud platforms. Yes, cloud platform. And we have several of them. We have Amazon AWS, that is Amazon Web Services. We have Microsoft Azure. We have GCP, that's Google Cloud Platform. We have several of them. So you will get to learn them and know how they work. And you have some of these collaboration tools like Jira, like Slack, like Trello, several of them. So this is the whole concept of DevOps engineering. In the subsequent videos, I will begin to teach on each of these DevOps tools. One like for the cloud platform, I will be doing a video on AWS. It's going to be a series on explaining the concept of AWS, and we will have a hands-on uh, practice to learn some of these things. So this is where we stop for today on this video. If you like this video, please click the like button, share this video, and please subscribe to my channel and click the button. I mean the the bell. Yeah, the bell, so that you can always get updates on my next video. Thank you so much for your time.